Hello?
Yeah, can you hear me?
Yes, I can hear you.
Okay, so thank you for joining. Okay, so where are you from?
Okay, I'm from Malawi, Africa, but right now I'm doing my master's degree in Thailand.
Okay, okay, good. Okay.
Yeah.
What's your
Yeah.
university name?
Talengi Kasambala.
Okay, okay.
Yeah, you can
Okay,
call me Tali.
okay, great. Okay. Okay, so basically in this time you want to learn about that peat fire burn using
Yes,
remote
yes,
sensing technique.
yes,
Okay.
yes.
So do you have select any algorithm or any method did do you find?
Currently, I'm still going through literature, but from what I've found, a lot of people use London Forest for because I'll also create a fire risk map. So for that one, I'll use London Forest, and then for the first one, I wanted to use my data set is from I want to use from 2010 to 2023,
Okay, so
but
10 years that you want to take in this time.
yes. So, but my supervisor was asking me to use from starting from 2010 to 2023. But the challenge is 2010 there was Landsat, and then Sentinel was launched later on, which is a high resolution set, right? It offers high resolution images. So I wanted also to learn how to band sharpen, band sharpen, I mean, yes. So
Yes.
yeah, those
Okay.
two. Yeah, yeah.
Okay. So in this time, you want to observe the peat fire burnt area between the time
Yes.
period year of 2010 to 2023. This time period.
Ye- Yes,
Okay.
yes.
So for that, you have to use the Lancet imagery, and
Mhm.
Lancet imagery. You need to use the pan sharpening technique to get the high resolution. Thus, as
Yes.
Lancet is mainly 30-meter resolution, but when you want to use the pan sharpening technique, you can get
Mhm.
the image for that 15-meter resolution about that.
Yes. Yes.
Okay. And for that, after doing these things, you want to apply the random forest algorithm and
Mm-hmm.
classify the burned region or burned area from these satellite images.
Yes, yes.
Okay. 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 So in this time, okay. So do you have any specific index such as bond ratio index? This type of index do you want to use, or otherwise just simply use the your spectral bands and make the
Mhm.
classification?
Um, I tried to use NRB, normalized band ratio.
Yes.
So I did for Sentinel, and then my supervisor was like, "Okay, I did the excellent work, but he wanted me to confirm whether that place really bent. So he said I should check the natural color image, and with the clouds, I don't know how to. I'm using Google Earth Engine, but I'm not good at Google Earth Engine. I just started using it,
Okay.
but yeah, yeah. So I saw that your a lot of your videos you're using Google Earth Engine. So yeah, I wanted help on that, and also for Landsat for 2010, I saw that whenever I code and whenever I check the bands, there's no band 8,
Okay.
which can be used for pan sharpening. Yes.
Okay. Okay. So in this time, okay. So can you share your screen and show me your code which you write for that in this time?
I've connected to my phone, so let me just connect to
Okay. Okay. You can
my
take the time and
yeah.
connect. Okay.
Oh, okay, fine. All right. So just wait a minute. I should send the link to my email.
No problem. You take the time.
Hello.
Please.
Okay. So, but my code is not it's not organized well because I was just trying this. I was just trying different codes. So, just wait a minute. Oh, sorry. I think I did not save it. It's gone back. Mm, um, mm, um, Hello.
Yeah, please.
Uh, oh, so
Okay.
should I share the
Okay, so in this time, you can simply go to the asset tab. You can simply go to the asset tab and click on your boundary shape file first. Asset tab.
say what?
Asset.
Oh, can I
Click.
asset?
Yeah. Click on asset, and then you can simply. Okay, so in this time, click on the shape file. Yeah, one.
Oh,
Click on here.
oh, can I just create another a blank project, a new project?
No need, no need. You can simply just I want to access your boundary from my site. Okay, then I can easily write the code and okay, click on here, click on here. Yeah, then click on the share button. You can see the share button,
Okay.
and further
All
anyone can
right.
read. Click on the anyone can read check mark. Yeah,
Okay.
tick mark. Yeah, then click to the done.
Done.
Yeah, done.
All right.
And now click on the get link button. You can see the get link
Get link.
here
I
at top
can
of the
see
code
it.
editor. You can see the get link. Get link, save, run, reset apps. So you can see the get link. Yeah,
Oh
click on
yeah.
yeah,
So
yeah,
now,
click.
so
Yeah, so
yes,
now
done.
copy and send me this link.
Okay.
Okay. Then I can easily access your
So
full code and check what is the
okay.
problem.
All right. So should I stop sharing?
Yeah, now you can stop sharing and send me the link. I can easily open this code from my side.
All right.
Okay, got it.
All right.
Now let me share my screen. Okay, so okay. Now you take the image for okay. Okay, so this is a study area.
Yeah, the study area.
You want to
Yeah.
identify from here your mainly pit burn area.
Yes. Yes. Yes.
But in this time, this satellite is image is totally wrong interpret. It shows this type of line or error. Okay, and your
Mm.
time period is that year of 2010 to 2023. Okay.
Yes.
Okay.
But for that one, I wanted to create individual, like for annual. So it will be an individual map for each and every year.
Yes.
Yes.
Individual index map you also need to create. Okay, understand. Okay.
Yes.
Okay,
Yeah.
so in this time, okay, so I will show you my summary or method. What I will do for here, I write this
Mhm.
summary. Then we just try to develop this code according this summary. So first
Okay.
of all, in this time, our methods. First of all, we take the image for the two time period, year of
Mhm.
2010 and year of 2023. Okay,
Okay.
mainly
Yeah.
in this time we take the image for Landsat imagery. Okay, for two time period, and further we are just create some one ratio index. So in this time you just put only for the one ratio index, mainly in this time with NBR. Okay, but in we are also get the some more index. So here you can see one kind of research paper. So in this research paper, you can see, if you want you can also use this type of index, such as you can see the band area index, BAI, mid infrared bar index, MIRBI, normalized band ratio index 2, and normalized band ratio NBR. Okay, so basically this type of index, when you can use in your machine learning model, then you can easily get the high resolution, you can easily get the high accuracy band
Mhm.
ratio mapping. Okay,
Okay.
as well as mainly if you want you can also add this type of index, suppose normalized difference vegetation index, normalized difference moisture index.
Mhm.
So we consider all of those index, suppose NDVI. Okay, all of those index we try to develop for this study area using Landsat and Sentinel, both of time
Mhm.
period 2010 and 2023. Okay,
Okay.
and also create the individual map, suppose band ratio map, then a BAI, this all of those index we create the individual map. Okay, after
Right.
that we are just use all of those index, as well as also use the other types of Landsat band, and make the random forest classifier, mainly random forest classifier, and classified mainly two class. One is that barn area, another area is not barn area. Okay,
Yes.
suppose you can see it's one already create this type of map in here. Mm,
Mhm.
yeah, suppose this type of map you can see, it's
Mhm.
mainly classified and find out the peatland and burned areas. So this type of red line map, so you can create the two classes map using random forest.
Okay.
Okay, so we are also add here the okay, I write the method. Suppose in this time we make the index for NDVI, we make the index for moisture index, moisture index, then NBR, then
Mhm.
NBR2 index. We also talk about that, and also another is the barn area index, BI
Index.
index. So in this time we consider all of those index. Okay, for this study area we create for individually, as well as we extract the pixel value. Okay, so in this
Okay.
time do you have any ground truth data for identify for that this is the barn area and not barn area, or for the barn area any ground truth data or no?
For now, I don't have it, but I'll get it maybe in few weeks to come. Maybe
Okay,
two
if there is
weeks.
the no problem. So in this time we are just use at the barn ratio mapping. This type of map we create, and we can easily identify this is the barn ratio, this is the high density of the barn. So from here we can take the training sample or training point for our machine learning model, make the random forest. Okay.
Mhm.
So after doing these things, third step we try to make for our mainly in this time we are just extract the band's pixel
Mhm.
values for all index. Suppose all index we consider
Yes.
as a band and extract the pixel value. Okay, as well as we also consider the near infrared band, red band, other types of band which are available in the Landsat imagery. Okay,
Mhm.
extract the band pixel value. And fourth step we are just mainly use the random forest.
Okay.
Okay, and doing these things in this time we are also okay, extract the band pixel value, and before that we also put the third step, get the training sample or training point, because random forest is a mainly it's a your supervised classification method, so you must need the training sample. Okay, we are just simply add some training sample, our classified area training sample, and then extract the band pixel value for each training sample. Mainly this type of bands we are consider, as well as we also add the other types of band. Okay, after doing these things we are just make use the random forest classifier, and
Okay.
further we are just classify our image, mainly our burn area and also unburn area. Okay, classify this image. Okay, further we are just check the accuracy, as well as we are also download the classify image as a
Okay.
TIFF format. Okay, and further you can easily make the map after downloading for represent your map using ArcMap or QGIS software for your research paper or other things. Okay, so in this
Yeah.
time,
All right.
this is our full method we try to follow, and then try to make this burn and unburn area for Peat-Fire. Okay, for this study area.
Okay.
So for doing these things, first of all, we need the Landsat imagery. So in this time, you use here the Landsat 7, but if you want, you can use for that, suppose Landsat 5. Suppose we take the time period for the Landsat 5 from here. Okay. Landsat 5 is also available for the 2010 also. So in this time, it's better to use the Landsat 5 because it's a thematic mapper image. So that's why in this time we are not get this type of scale line error or other things. It's not coming. And from here I just choose the surface reflectance. So basically in this time, okay. And we also need to, okay, another thing is missing in here. This another thing is that we also need to reduce this resolution, increase the resolution. Okay, so in this time after taking the image, we are also use at the pan
Yes.
sharpening to increase the
The
resolution
resolution.
15 meter. Okay, for the pan sharpening we need a one band, this band called the panchromatic band. Okay,
Yes.
so first of all check about the it's available or not in here for the Landsat 5. Blue, green, red, near panchromatic band. LQA. Okay, I think here there is no panchromatic band for the Landsat 5. Okay, let's check about that Landsat 7. Surface reflectance. And here we can get blue, green, red, near 2.
Yeah. I think there's no 0.8.
And 6 surface temperature not. Okay, so but what is the process for that panchromatic for Landsat 5 and 7? Okay, I also try to find out the solution about that. I think some method is available for that. But Landsat
Right.
8 is available for the panchromatic band B8. Okay, so that's why we can easily use it for the panchromatic band and easily make this, you can see. Oh, panchromatic band is available for the top atmospheric, I think. Yeah. Yes. So I think okay, so it's not available for the surface reflectance. We can get the panchromatic band which 15 resolution in the panchromatric. So I think it also available for that. Also Landsat 5 and Landsat 7 in the top of atmospheric. So in this time, you have to use the top of atmospheric satellite image because you want to use at the panchromatric band, and panchromatric band is available only for the top of atmospheric image collection. So here you can see, is there no, okay, is there no band about that? I think panchromatric band is added from Landsat 8 set collection. Okay, so for that in this time it's no band about the panchromatric. Yeah, so we try to find out the another way to make increase the resolution for this Landsat 5 and Landsat 7. So but Landsat 8 and Landsat 9 is available for the panchromatric band. Top atmosphere. AB8 is available. Okay. Okay. First of all, we try to make this 2023 and use date what we can get. Suppose year of 2023, 1st January from year of 2023, December 31, filter bounds and median, and finally it's sleep with master area. RY. So just put here this. Okay. Further, layer and call the image. Run. We can get this type of image. So click on here. I want to set the band combination. Suppose red, green, and blue, and custom reflectance. Suppose 98%. Apply it. In this time we can get some cloud and also get some this type of things. Okay, so for that we also need to remove the cloud and also increase the your mainly increase the resolution using the panchromatric band. Okay, so first of all I write the code for that, removing the cloud. And this band name is that QA pixel. You use this band for removing the cloud. And we remove the cloud and cloud shadow with 3 and 4. So just put here. And then then call the image and use the select this band QA pixel. Take a variable, suppose cloud bit max, and use that one less than bit number for 3 and 4. Okay, so just put it the 3 and take another variable, suppose cloud shadow, put one less than 4. Then take another variable such as max, and I call this QA, connect with my band, so bit wise, and call this cloud bit max set equal to 0, and also call the QA bit wise and call this cloud shadow set equal to 0. So this is our code. So now further simply copy this variable name max to clouds and paste after the collection. So this is my collection. I just use here the map function and connect these things in. Now check. Okay, so the wrong is not a function key. Okay, so this problem is that out bitmarks is equal 0. So now let's check. Okay, we have to use at the return image update marks with this variable. Simply copy and paste it. So now let's check. And in this code, you can also put the another function. Mainly, it's called the filter metadata. So suppose I need for this cloud cover less than 0. And I hope now all of this cloud is already removed. Just check from here what is the condition. Suppose red, green, and blue. Custom 98%. And apply. Okay, almost remove all of this cloud. You can see.
Yes, yeah, you can see it.
Because in this time, suppose if I did not use it, this function, no problem, because I remove all of those cloud using this function. Okay,
Oh,
so in
okay.
this time we can get the this type of image. Okay, and this image there is
Okay.
no cloud, year of 2023. Okay, so these are one image you can take for that. So now this image we have to use at the panchrometric and then further increase the resolution. Okay, so I simply import this color, simply import in here, import, and simply copy this variable name from here and paste or paste our object name. So this is the object, or paste here. You can put this image 2023. Okay, so we can get the Landsat 8 satellite image for 2023. So further we have to use at the panchrometric to reduce this um, pixel area and increase the resolution. So for doing these things in this time, I just try to, okay, so I just use the previous code. It also better save our time. So I just try to open this code for that mainly panchrometric code. So just I simply search here because I already save it. And if there is suppose any kind of ground truth data, then it also easily identify. Suppose this area region is for the pit burned region. This type of ground truth sample if you have, then it is also better to make the map. But in this time we have to use here that different types of band combination from here, as well as also use this type of band, mainly this type of band in our paper. Then we can easily get the idea where the band ratio is high. Suppose this type of, you can see BAI index, MIR BI index, NDVI index. Okay, so this type of index we try to develop. Then we can easily get where the band ratio is high and where the band ratio is the low, and from here we can easily connect, get some training sample, and further we use here that random forest algorithm to identify for the pin burn area region. Landsat map. So just I simply copy this code from and paste. And further, I just simply from here the some code, mainly pen sharpening code. The code I simply copy from here and paste in our code. Right, yeah. Paste. And further, simply copy this variable name, user.map, and paste this variable name. Okay. So now we can get the 50-meter resolution immediately, because in this time I consider the pen sharpening function with that, and now it's increased the resolution.
Okay.
So now it's pen sharpening in this time, because I use this code, it increased the resolution about this image also. Okay. So in this time, after doing these things, in this time we are just need to calculate some index. Okay. So this we have to calculate some index. So I remove all of those things. In this time, after doing these things, we are just simply calculate this type of index, such as you can see which index in here already available for that. Suppose okay, just I simply find out the formula. So this is the formula. So suppose you can see this is the ratio about the band area index. Okay, BI index. So this index we try to develop. Mainly we have to calculate this formula. Also you can see this type of index. This type of index is just simple, right? So first of all, suppose I just try to calculate the BI index. So I simply copy, and then further we are just okay, right in here. So just take a variable, suppose BAI, and then I call this emails and use at the okay. So in this time, okay, there is a lot of way to calculate that. Suppose in this time, I need which band in here. You can see I need the near infrared band and also red band. Okay, near infrared band, red band I need. So for doing these things, I just take a variable, suppose red, and call my image. From here I just simply select the red band mainly before. Okay, and also I need the another band, near infrared band. So I call this image. From this image I just select the near infrared band. B5 is the near infrared band. So further I simply calculate the equation. Mainly this equation is that 1 divided by 1 divided by near minus 0.06 whole square red. Okay, so just we try to find write this equation, 1 divided by near minus 0.6. Okay, so in this time put here near minus, so subtract, sorry, in this time 1 bi equal to 1, you have to use that the divide function, 1 use that the e dot number, then put the 1. Okay, this one is divide. Okay, divide with near, subtract with 0.006. Let's check the value again. Okay, 0.006 and power 2. 0.06 power 2, 0.06 then power 2. So for this power 2 we are just use here the POW pow and define here the 2, so it's called the power 2. And in this time we are just put the parenthesis in here and also close this parenthesis in here. Okay, so now it was 1 divided by near minus subtract 0.06 power 2, done. Okay, after these things, this last part is that plus red 0.1 whole square, red minus 0.1, like red minus 0.1. So just put here add So add mainly red. So call the red, then subtract with 0.1,
Um,
0.1 power 2. So just use here the POW power 2. Okay. And finally, okay, it's done, no problem. So these things, I think, okay, we have to put these things red and put here the power 2. Okay, then further close, and so further close. Okay, so now this is our equation we put in here, and further I want to show this map. So map dot add layer PAI run. Okay, so okay, so cannot re-add object number to the map. Okay, so in this time we have to put this type of things. We have to convert. So ee dot number. Okay. Also put here ee dot number. Also put here ee dot number. Now let's check. Okay, so this equation is not qualify. Or okay, I think so. We try to have another way. Just a minute. So for that, just take a variable, suppose PAI, and I call this image. Use here the expression. Okay, expression. I put my equation. Suppose 1 divided by mainly it's
Near
minus 0.06. Okay, and power mainly 2 multiply then 2, it's power. Okay, and these things I need to add. These things I need to add with my it's mainly add with our red. So just I put the parenthesis and put here the red. Okay, and red, and then plus 0.1, and it's power 2. So power 2. Okay, further I just make the parenthesis also in here, parenthesis. Okay, so this is our equation. Okay, we don't normally put, and further we have to define about that what is the near, what is the red. So just I put here the curly bracket and define. Suppose near, mainly this near. I already select the B5 in here. I simply put here the near, and red, mainly this red which is stored the band 4. Simply copy and paste here. Now further I simply comment these things and try to run the code again. So now click run. I hope now it will be work. Yeah. So now we can get the one index BI. So we can get white color, no problem. We just set the visualization from here, click on here, and further you can simply custom such as 98%, and then apply. And further I think whole things we just make this parenthesis, close this parenthesis. Okay, I'll check again. Okay, now further click on here.
Okay.
That's 98%. And apply. Okay, so now we can get this type of map about that bond ratio. So
Mm-hmm.
we set the color plated. Suppose we set the low value such as this type of blue color, low value. Then high value we show this type of suppose green color. Then we show suppose this type of yellow color. Then high value show this type of red color. Further apply. So now it create this type of map. Okay, bond ratio map. So basically this type of region, red color region, identify about the high value of this bond ratio index or
Oh,
BI index.
mm.
That was just simply yeah. So this type of region, I try to open the satellite map from here also. Then we can easily get that what is the background on this region. Was this type of region, what is that? So the water body.
Yeah.
That
This one is a river.
okay.
Mm.
What is that?
I think that's peat. It should be a river, right? That's from what I made last time using Sentinel. I was also confused with the river channel. It was also showing that it was plain, so I was confused there.
Okay, so in this time, I suppose this type of thing, suppose this type of color identify about this. It's the bond area or what is it? Is a barren land or what is it that? Is there any way to put in here for that barn area?
To do what?
Suppose a peat barn area is available for this region.
Mm, you mean the data?
Yeah, so in this time we can get the high value for the barn ratio for this area. You can see.
Oh, okay.
Okay, so not only for that, we also try to add the other map for the barn ratio and then compare it. Is it correct or not? Okay, just simply paste after this index and put at the barn area index. Okay, I put this name. In this time I want to develop this suppose mid infrared barn index. So MIB. So just I simply copy this equation. Okay, so in this time I simply calculated that MIRBI. So just simply go to here again and then take a variable MIRBI and call this image and use add the expression. Mainly it's just okay. So mainly 10 multiply with short wave infrared band 2. Okay, so is the SWIR. Okay, just I remove that. Not work correctly. So just suppose 10 is 10 multiply with SWIR2 band and further minus 9.8, minus 9.8. So just put here the negative 9.8 and put here that multiply with short unified 1 plus 2. So multiply SWIR1 plus 2. So these are equation. So just I make the curly bracket and put here. So SWIR2 mainly it's the image. It's come from this and select the image. Short unified 2 mainly B7. Okay. And SWIR1 it's mainly or image B6. Okay, we have to use that the comma sign. Okay, so now further we are just add it. So suppose simply map dot add layer. Done. And further click on here. Layer. And further just click on here. Custom success 98% and apply. So now we can get this type of map. Submit infrared burn ratio index MIRBI.
Okay.
We can get, suppose in this time I also add the color. Click on here again. Let suppose low value I want to show as the blue color. Then get it, then I use the green color. Then use that this suppose yellow color. And high value I want to show as a red color. Then apply. So now we can get this type of value. What is that? It's a water body. So water body show as a high reflectance value for this those ratio. And what is that? Okay, so it's the water body.
Yes, sir.
So I think okay, so there is no water body, but it also show about the high value of the MIRBI. Okay, so I think this pixel is for that burn ratio pixel, because in this time there is no water, but it also show about the still high reflectance of the MIRPI index. Okay, so it's considered as a I think burn area, as well as you'll check about that. Okay, it also about that you can see it's a vegetation. There is no burn water body, so you can also take the training point from here, also correct the training sample for that this ratio. So further we are also take this type of other course. Also you can see the normalized burn ratio to, also you can see this is the normalized burn ratio. So this type of things we calculated also, and also make individual map. Okay, and after doing calculating all of those things, we are just extract the band pixel value. Suppose we are just take the some training sample, such as band ratio, band area or not band area, or water body, or vegetation, so or build up area. We're just simply some classification. Such as in this time, you just make the classified for the water body, then suppose build up area, then barren land, barn area, and not barn area. Okay, then we are just display this result from here. Okay. Okay, so you also try to add the more index, other index in here, same process, other index you try to add in here. And in the meantime, I also try to find out the solution about that, how we can easily use the panchrometric for the Landsat 7, Landsat 5, this type of image. Okay, because in this time we did not find out the panchrometric band. Okay, so I'll send you the code. You also try to add other index.